Okay, so I'm just going to do the memo for our first weekly test for the 214 course now in 2016. Overall, you guys did okay, but perhaps in the chemistry that's involved in all the information you need to know from last year was maybe a bit rusty. This first question over here, the structure of toluene, is just one of those fundamental structures and molecules that you need to know. It's a methyl benzene. But more importantly than that, I've handed out a list of common organic solvents, and toluene is one of them, that you do need to know the structures of. I know it's not great having to learn a whole lot of things, but every chemist or any person who's done a chemistry course will know exactly what toluene looks like and acetone and things like THF. So you do need to learn them, unfortunately. This one over here should have been a fairly easy question, but I think many of you were missing this, just the number of pi bonds in it. Obviously each double bond here, this is 1, 2, 3 pi bonds, but of course the nitrile is the hidden one, and there's 2 pi bonds in the nitrile, so that gives us a total of 5. Okay, and then the question 3, moving on. Question 3 was also answered okayish, but I think a lot of you are forgetting the names of functional groups. So methyl ethers are OMe. You could have written CH3 or just a line to that would have been fine. Meta to each other means that they 1, 3 positions. So I could have either put the next group here or I could have put it over here. It doesn't matter. And an isopropyl group, again, this is just one of the absolutely fundamental kind of functional groups that you need to be able to recognize as a chemist. So please make sure that you know these substituents. This question over here was answered very well, and I think it's because I've been drumming this into you in class, so it was fairly easy. Obviously, the energy level goes down when you form the molecular orbitals, and then it goes up as well. We marked that's the sigma bonding orbital for the 2 hydrogen s orbitals, and this will be the sigma star. So that was answered very well. Obviously, in the bonding orbital, we have our 2 electrons. And then the shape of the orbitals, you have to draw the sigma bonding orbital is going to look something like that with the 2 centers of, so somewhere in there, the 2 electrons. And then the anti-bonding orbitals look something like this. I gave an extra half mark if you recognize, of course, that the anti-bonding, there's a symmetry to them, or there's a phase change between the 2. So there's a node in the middle, so the one should have been shaded in or plus or minus associated with it. But I gave an extra half mark if you got that right. And then the last question, again, I think we've drummed this in to you so many times now that you've got this, so well done on that. So why is the 2s orbital in nitrogen lower in energy than the 2s orbital in carbon? And the answer to that is that the nitrogen is more electronegative. And that was done very well. Okay, so that would have got you your 10 marks, maybe even a bonus mark for 10.5 on that. But good luck with the rest of your studying.